Today's episode is about space, time, and the nature of reality. My name is Gabe, and this time it really is space-time. If you pay attention, this episode is going to blow your mind. So we're going to take it slow. What is space-time exactly? Before I can answer that, I need you to do something for me. Give up your intuitions about how time and space work. At first, your brain might resist and hold on to those intuitions for dear life. Don't worry, that's normal. This is challenging for everyone, even Einstein. Ready? Okay. Space-time refers to whatever external reality underlies our collective experiences of the space between things and the time between events. Why can't space and time just be reality? Why add space-time as an extra concept? Here's why. Suppose two observers are moving relative to each other, and particles count as observers. Fact: those observers don't agree about how much time passes between events. Fact: they don't fully agree on how much space there is between things at any given moment. Fact: they don't even agree on the chronological order of all events. And yet, each observer measures things properly and is entirely consistent, which means neither of them is wrong. Now that sounds absurd, but it's true. Plenty of other resources, some of which we link to in the description, discuss these discrepancies and the experimental evidence for them. For today, we'll just take them at face value and focus on what they imply about the nature of reality. Because if you think about it, some of the implications are staggering. Take this disagreement about sequence of events, for instance. It is severe. If two observers can't agree on the sequence of events, it means that at present, someone's past is in someone else's future. Now for nearby events, the effect is microscopic, but so what? Any disagreement means that there is no universal division of events into past, present, and future, which opens major philosophical cans of worms for things like free will and our belief that we can change the future. So, is everyone's experience of the universe entirely subjective? Or, phrased another way, if time and space as we usually conceive of them aren't part of objective reality, then what is? Causality. Let me explain. A good starting point for objective reality is universal agreement. And, as luck would have it, all observers do agree about this thing. It's called the space-time interval, or space-time separation, between two events. Even though two observers in relative motion will measure different distances and different elapsed times between the same two events, they always agree about the space-time interval between those events. Now, if everyone agrees about space-time intervals, they must signify something. But what? We'll notice that since it involves subtraction, a space-time interval can be positive, 0, or negative. When it's positive, nothing can get from one event to the other, and there are always observers who disagree about which one happens first. When it's 0 or negative, signals or things can get from one event to the other, and everyone agrees on their sequence. So, it appears that the space-time interval between events A and B tells you whether A can influence B. In other words, even though we can't agree about past, present, future, time, or distance, we all appear to agree about causality. Now that may seem counterintuitive. Normally, we think that time is responsible for causality, but actually it's the other way around. To the extent that we agree about temporal anything, it's only because of causality. Causality is what's real. So what does causality have to do with space-time? As it turns out, everything. See, shortly after relativity first came out, a former math professor of Einstein's named Hermann Minkowski noticed that the space-time interval resembles a weird version of a distance formula in what's called a non-Euclidean space. So he proposed the following radical idea. Maybe reality is not a three-dimensional space that evolves in time. Instead, it's a four-dimensional, non-Euclidean mathematical space that's just there. No evolution, no time. That 4D mathematical space is space-time. Its points correspond to events. All events, everywhere, ever. And in this view, only things that correspond to geometric relations in that 4D space are objectively real. Like, for instance, causal relations. They correspond to space-time intervals, which are geometric relations, a non-Euclidean version of distances between points. In contrast, our experiences and measurements of time and space don't correspond to anything per se. They're more like the XY grid we use in math class, useful for talking about the board, but arbitrary and inherently meaningless. The board, its points and geometric facts are simply there, whether we put axes on that board or not. So are you objectively real? Well, kind of. If you are the sequence of all events of which you are present, then you are a geometric object in space-time, a line segment, joining the points representing the events of your birth and your death. Do you move along that line segment? No. You are the line segment. There's no motion through space-time. It's not this kind of space. It's tenseless. And your future isn't merely predetermined, it already exists. There's some zen in trying to express what space-time is without misleading you, but I think the following gets the flavor right. Imagine we're all reading a flip book made of graph paper. We agree on the events of the story, but we don't agree where they happen on the page, on how many pages there are between events, or even on the order of some of those events. And yet, we're all reading the same book. Only, there's no graph on the paper, there are no pages, and there is no book. All of that is just an imposition our brains make in order to perceive whatever it is. So why do we perceive reality in such a vividly spatial and temporal way? Good question. No one really knows. So have I told you all there is to know about space-time? No, far from it. All of this has just been a loose introduction to what's called flat space-time. Once general relativity enters the mix, we'll find that there are many possible spacetimes with different geometries, making it hard to ascertain which one this is. But we gotta crawl before we walk. We will get to that fun stuff eventually though, so subscribe. And as always, the comments are for your questions. I'll do my best to answer them at the next causally connected point of spacetime.